All right, hello everyone. Welcome to chemistry, our chemistry unit, atomic mass, atomic number, and charge lesson. Today's learning targets are identifying an element by its atomic number. I can determine the mass number of an atom by adding its protons and neutrons, and then I can determine the net charge on an atom by using the number of electrons and protons in an atom. Today, your job is to take notes on this Edpuzzle video. And then once you've completed the Edpuzzle video, the expectation is that you come to your hours live Google Meeting. If you have Mr. Oleg, that hour is at the beginning. And if you have me, that would be later in the hour at the end. So without further ado, let's start talking about atomic mass, atomic number, and charge. So when we talk about atoms, we need to talk about elements as well. So early on, when they first started talking about elements and trying to organize all of the different elements, John Jacob Berzelius introduced the symbol notation on Latin names. So things like iron were named after or given the symbol Fe after the Latin name ferrous for iron. Or gold got the abbreviation AU because AU was the beginning of the Latin word for gold. Later on, they looked at using the first or second letter of the English name to symbolize the elements. So, for example, helium is He, lithium is Li. And this is the system. So that's why some of them seem to be goofy or seem to be off, is because some of them are based off the English name and some of them are named off the Latin name. When we look at the periodic table, they're organized into all these different things. And as we get into the class, you're going to notice that there's a pattern between where they are and what characteristics they have. So the first thing that we need to know is that the periodic table is organized by atomic number. What is atomic number? Well, the atomic number is equal to the number of protons in that element. So every element, right, is going to have a specific number of protons. Every hydrogen atom will have one proton. That's what makes it hydrogen. It's the number of atoms. It's essentially the identification number, or the ID number. So you can identify an atom based on how many protons it has. You can tell us what type of element that is. And all atoms of the same element have the same number of protons. For example, all iron atoms have 26 protons, or all carbon atoms have 6 protons. Other things can change about the atom, but as long as the number of protons stays the same, that atom will remain the same element. So if I was going to look at this in a sentence, all atoms of oxygen have 8 protons. The atomic number is listed at the top of the element symbol. So the atomic number is the number above the symbol. So this is the element symbol for oxygen. The O is the letter representation. The atomic number is up here on top, and it tells us that its atomic number is 8. And because its atomic number is 8, we know that any oxygen atom is going to have 8 protons. Right? Atoms on the periodic table are all neutral, meaning they don't have a charge. So they're neither positive or negative. Because of that, there has to be an equal amount of positive charges and negative charges. And yesterday, you learned about protons being positive and electrons being negative. So if an atom is going to be neutral, that means that the number of protons needs to equal the number of electrons. And then all of our atoms on the periodic table, as we see them on the periodic table, the number of protons equals the number of electrons. So if an atom is atomic number 82, it has 82 protons and it has 82 electrons. That is if it's neutral, and that's the way we find them all on the periodic table. If you know the number of protons, or if you know the atomic number, you're also going to know the number of electrons, which is a pretty good deal. An example, if an atom has 15 protons, it's going to have 15 electrons on the periodic table. Then we'd look at a periodic table and we'd see, ooh, Element number 15, or atomic number 15, is phosphorus, right? And we knew that because we knew the number of electrons, we knew the number of protons, and that way we could figure out the atomic number. So we're going to give you some practice time. You're going to need your periodic table that you can find under the materials in Google Classroom. Let's go through this, all right? How many protons and electrons are in the following neutral elements, meaning they are the same? All right, ready, set, go. Hopefully you had enough time to get that done and you did a good job. So if we look on the periodic table, gallium, it is atomic number 31. That tells us that there's going to be 31 protons, and if the atom is neutral, it's going to have 31 electrons. Silicon is our next one. If we look at the periodic table, silicon has the atomic number 16, telling us that there's 16 protons, and if it's a neutral element, it's going to have 16 electrons. Cesium on the periodic table is number 55. That tells us it has 55 protons and 55 electrons. And then calcium is our final one. On the periodic table, calcium has 20 for an atomic number, meaning it has 20 protons. And if the atom is neutral, meaning it has no charge, it's going to have 20 electrons. So where is all the mass of an atom? Yesterday we talked about protons and neutrons having mass and electrons really not having much at all. So really all of the mass is going to be in the nucleus where we find protons and neutrons. When we look at the mass of an atom, we look at the mass number. And that's equal to the number of protons and the number of neutrons in the nucleus. So a simple equation, mass number is equal to protons plus neutrons, or the number of protons plus the number of neutrons. If we look at it in this problem, our mass number is found at the bottom of the atomic symbol. It's found at the bottom of the atomic symbol. If on your periodic table it is a decimal, round up or down to the nearest whole number for now. We'll discuss why that number is a decimal later on. So if mass number equals protons plus neutrons, how many neutrons does oxygen have? Hopefully you figured out that oxygen has 16 for an atomic or for a mass number, and we know that the atomic number is 8. Atomic number equals protons. So mass number is 16 equals 8 plus neutrons. So how many neutrons does it have? It will have 8 neutrons. So on your own, I want you guys to practice this problem. Fill in the missing numbers. All of our atoms here are going to be neutral. Ready, set, go. Okay, hopefully you did just fine on that. We're going to go over it. So our first element here has an atomic number of 3. If we look at our periodic table, we're going to see that atomic number 3 is lithium. All right, so atomic number is also equal to the number of protons, because atomic number equals protons. If the atom is neutral, we know that the protons are going to equal the neutrons, and that will give us 3 electrons. Excuse me if I said neutrons earlier. And then we know that the mass number is equal to the number of protons plus the number of neutrons. So we can take our mass number and subtract our number of protons to give us our number of neutrons. And 7 minus 3 is equal to 4. Our next atom, if we look on the periodic table, it has an atomic number of 15. That atom is phosphorus. Phosphorus, because it has an atomic number of 15, is also going to have 15 protons. And because it's a neutral atom, it has to have the same number of negative charges or electrons, giving us 15 electrons. And then to find our number of neutrons, all we need to do is take our mass number and subtract our number of protons to find our neutrons, because protons plus neutrons equals mass number. And 31 minus 15 is equal to 16. So that's how many neutrons are in phosphorus. So we've already talked about atomic charge a little bit because we talked about atoms on the periodic table being neutral, meaning they had the same amount of positive and negative charges. Well, what happens when those aren't the same? An atomic charge is determined by the number of positive and negative charges within the atom. So one proton equals one positive charge, and one electron equals one negative charge. From there, we can figure out how many positives and negatives it should have. If an atom has more protons than electrons, more positives than negatives, it will have an overall positive charge. If that atom has more electrons than protons, it will have a negative overall charge. So here's an example. I took the numbers from last time, right, the two atoms, and I put in a different number of electrons. So we can see that lithium still has an atomic number of 3. That means it will have 3 protons. But if it has 4 electrons, that gives us 1 extra negative charge. And we get lithium with a negative 1 overall charge. Down below, we saw that phosphorus will always have an atomic number of 15, meaning phosphorus will always have 15 protons. But if phosphorus has 2 less electrons, 13 electrons, it would have 2 more protons than electrons, meaning it has a plus 2 positive overall charge. Your job now is to fill in the missing materials, all right, to determine the charge of the atom. You're going to need your periodic table to complete this. Ready, set, go. Okay, so I made a few mistakes here in what would actually happen, but it's totally okay for us to do this. So to start off, the atomic number for chlorine is number 17. If you look on a periodic table, that's where you find chlorine. It makes sense because chlorine has 17 protons. And 35 minus 17 gives us 18 neutrons. Now, in reality, it would have actually 18 electrons, but I mistakenly put 36. Well, we can still figure out what the charge would be. All we need to do is we need to take the difference between the protons and the electrons. So if I have 17 protons and I subtract 36 electrons, I end up with a charge of negative 19. That's how many more electrons there are than protons. So the atom would have a negative 19 charge. Now, in reality, that would never happen. It would actually have 18 electrons, and it would have a negative 1 charge. That was my mistake, but this should still work. Down below, we have nickel. Nickel has an atomic number of 28, which tells us it will have 28 protons. And if you take 31 plus 28, you get a mass number, because that's our neutrons plus protons, of 59. Now, because we have 28 positives and it tells us we have 26 negatives, what we'll do is take 28 minus 26 to get our answer. And we'll find that nickel here has a positive 2 charge. So that's how we do these types of problems. So to recap today's lesson, you should be able to identify an element by its atomic number. Then you can determine the mass number by adding the number of protons in an atom plus the number of neutrons. And finally, you should be able to determine the charge of an atom by using the number of electrons and protons in that element. Thank you guys for watching. We will see you at the Google meeting today if you have me. And please reach out if you have any questions. Thank you.